Hello everyone. So today again we have a question, and thank you all for posting questions. And this is a very good, I would say, support to the channel that you are giving, Rishi. Please, guys, come on. You can ask questions in the daily question and answer that I post. Okay, so basically you ask your questions, if possible, even give your links and data sets so that I have a little bit more context. And we can definitely grow this particular channel into a good community, to a healthy community of we can have good discussions and all those things. Okay, so let's get to the question. So the question is, please cover autoencoders from a theoretical point of view. An overview will also be fine, and writing them from scratch. So writing them from scratch, already there is a video on my channel. So I have both. I have normal autoencoders as well as normal autoencoders as well as your convolutional autoencoders. Okay, so these are very easy concepts. I can definitely give a simple overview over here. It's not difficult. It's very, very simple. But yeah, please, keep asking questions. It's a very important thing, I believe, for this channel. And let's start with autoencoders. And yeah, one more thing. So super thanks has been added to my channel. I didn't knew. I did not know, but those guys from YouTube, they were very good. They were very helpful when it comes to letting me know that there is a super thanks. So in the, this is the video, there are subscribe button, there is like button, and then there is three dots over here. Okay, if you click on three dots, you will have a kind of a heart, and in that there is a dollar sign. Okay, so generally you can give some dollars. Those dollars will be used for equipments. Okay, it's not going in my pocket. So better equipments, better we'll be able to buy camera, all that stuff. Okay, so autoencoders, let's get started with that. Autoencoders, fine. So what is an autoencoder? Autoencoder is basically nothing. It's a neural network, okay, that is like going down. So there is a this is called the latent space, or basically this is your bottleneck, as we say. Okay, there are very few neurons over here, and then what we do is we try to reconstruct back our input. So let me first explain it over here. Yeah, so basically what is there, generally you will be giving here your images, right? So let's say there is a MNIST image, MNIST. Okay, so MNIST data set. So let's say this is a image of a 3. Okay, so MNIST is 28 cross 28. Okay, so what we will do is we will take all these particular, these are grids. We will take, okay, first column, so this will be 28. Then instead of this one putting in the side, I will put it down. I'll flatten the entire image. Okay, so it will again 28, and again the third column over here, it will come over here. So we'll take all the columns and put it in one row. So up till there will be 28. So it will be this entire thing will be each of these what to say column is 28, and how many columns are there? 28. So 28 into 28, that is I think it's 760 or 784, whatever. Okay, so 764 or 784, whatever, just check it. Okay, so you will have 784 inputs over here, and then here, let's say here you will have only 10. Okay, 10 neurons over here. So from 784 we will be compressing it to 10, and then what we will be doing, we will be having this so this part is called encoder, this part. So this part is called an encoder, and this part is called a decoder. Okay, so from an encoder you have a very small bottleneck, so there are not many neurons, less neurons over here. Okay, and then what we will do, we will try to reconstruct that same image, whatever we gave over here, we will try to reconstruct the same image over here. Okay, by flattening and all that stuff. So what is the idea? This is helping in compression. Why? Because after this model is trained, we will take and we will throw away this decoder. So whatever we given as an input, we get a compressed 10 neurons out of, so 784 neurons converted to 10 neurons. So data is so much compressed. Okay, so let's say you are having to send some images through let's say internet. So your image is, let's say it's 10 MB, your image file is 10 MB. By compressing it over here, you compressed it to 1 MB, or even smaller than that, let's say 100 KB. Okay, so and you can pass this, okay, to your image through the internet to the mobile phone over here, and mobile phone will have a decoder. So we'll not exactly throw the decoder, we'll put it in the mobile, and the mobile will get this particular compressed version, and the decoder will be used to uncompress that. So obviously it's going to be a lossy compression. In fact, all neural networks are nothing but lossy compression of the data set on which they are trained. Okay, this is not a what to say your any statement that I read in any book. This is my personal understanding. Okay, so do not quote it anywhere, but yeah, mostly it's just all neural networks are compressed versions. But again, it's not a guarantee, because what if you just trained your neural network on one image? Then it's not a compressed it's basically random. Okay, it's random only. Just one image for one epoch is not going to do anything. So it's not a do or die situation or do or die statement. It is but let's say you have a good enough neural network that is trained on a good data set and stuff, you can say it's a compressed version of your data set. Doesn't matter what it is. It can be, chat gpt, or it can be a very hi-fi, whatever hi-fi type of a model, is doing nothing but compression of images, or compression of text, or compression of wikipedia, or compression of whatever it is. That is what it is doing. Again, generative ai is nothing but a deep neural network, nothing much. Okay, it is just a compressor. Okay, so yes, you can use this compression for generation. Why? Because now let's say you had this at autoencoder. So the encoder part is used for compression, right? But what if we are using the decoder and passing it values that haven't been seen? We haven't seen these videos with these values on the what to say, or latent whatever two neurons are there. Can't we say this is also used for generating, gen ai generating? Yes, we can say that. Now, the debate is not whether it is good or bad. Obviously, it is bad, and I'll tell you why. That's why you need a variational autoencoder. Okay, but the idea is you can have new vectors that you will pass in over here. You'll have new vectors that you will pass in over here, compressed vectors that you'll pass in over here. That has nothing, because you already thrown the encoder part. So you don't have the encoder. You only have the decoder left with you. So what you can do, you can pass in some values and then expect to get a new image. Okay, this is how it works. Now how you train it? Simple. This was the encoder part, and this is the decoder part. Mostly it's going to be symmetrical about this point. Okay, whatever is the architecture here, opposite architecture here is perfectly symmetrical. Okay, obviously the last neurons have to be same. So let's say you gave inputs over here. So you want to get the same output. Okay, over here also you want to get the same output. So what you will do, you already have the input and you have the predicted output over here. So you would want to reduce the MSE loss. Okay, so you gave pixel values over here, you got some values, and you want to reduce the pixel value. Whatever image you got here, same image you want it to be generated. And how far the image is, let's say this is the image, then whatever the distance of this image is MSE loss. Okay, so MSE loss. I have covered this particular idea a couple of times on this channel, and that loss will be backpropagated. So this is an overview, general overview. Now what is the problem with this? Generally it leads to overfitting. I told you it's a bad idea. Why? It leads to a lot of overfitting. What tends to happen is, instead of learning the distribution, it just learns points. Why? Because it has, now why this is there, you need some experience with that. Okay, but the idea is you should be learning a distribution. What it does, instead of learning a distribution, it just learns points. So this is nothing but overfitting, because we are trying to lesser the MSE loss. Okay, so you want a normal distribution, you get such a normal distribution, it's almost like this. This is normal distribution, yeah, but the standard deviation is way low. And yeah, you don't want this, because why? You will be only generating the same images. It is just and vicinity is not known, only that particular image is known. What you want is a distribution. Okay, that's what we use VAE, but that is out of the scope. Let's say you use also KL divergence, you try to learn a distribution. Out of the scope. If you don't understand, don't worry. So that was the idea. From a theoretical point of view, writing in yeah, so I already have a video on this channel. You can go in the search button, you can on the YouTube search, you can say datum learning, and then you can say autoencoder. Okay, you will get that particular video. If I'm not wrong, I have actually implemented from scratch. If not, then I will think if I can upload the video where I write it line by line, because it's been no more than a year. Okay, but I remember doing it, so it's there. Yeah, So thank you very much. If you have any questions, please, you can use the comment section, or every day I put a Q&A. You can go over there and put your questions. Very, very important. I read all the questions. I either put a thumbs up, or, I put a heart to it, whatever the case is. Okay. I do read all the questions and try to answer them as soon as. So if you are giving any kind of project, or you're giving any kind of, suggestion or anything, if a link is possible, okay, if it makes sense to share the link or the data set, please do it, so it gives me better context. Okay, so I hope you will like the video. Thank you very much, and bye.